Welcome to my video on looking at Riemann sums with the idea of accumulation rather than area under a curve. And this topic is not in a lot of textbooks, so I'm going to make a video just to have you think about Riemann sums in another context other than just area under a curve. So what we're going to do is, here's my typical definition for Riemann sum. It's the same as I usually have. But we're going to let f of x be the same thing, defined on a closed interval, get partitioned. Our delta x is the same as before, just the width of the intervals. And then our Riemann sum is going to add up all of those f of xi star times delta x. The difference here is not the definition of the sum, but how we're going to think about this f of x. So that f of x we want to think about as a slope rather than the height of a rectangle. So there's kind of a paragraph here describing that, but the idea is we're going to take this f of x as a slope. So I look at a slope right there, and we're going to have that f of x times delta x. And this f of xi star, since it's a slope, I can think of that as delta y over delta x, change in y over change in x, and then times a small little change in x again. So if I just cancel those out, then we're going to get this delta y. So what we're really adding up is all these delta y's over these small little intervals. There's a few drawings here already done of what that looks like. So a left-hand sum would be using just all of these left points on our function right there as our slopes. So this would be like a slope 1 right there. So we follow up a slope 1 over that delta x interval. Slope slightly less than 1, follow that. Next one. Right there's a slope of 0, so you just go straight across. And you just kind of follow that path as you build that function right there. So you go ahead and build that path, and then at the end you look at, all right, I started here, I ended here. What is the difference in that height? What is that change in y that accumulated over that period of time? So this is going to be rather small. If we use a right-hand sum, pulling our slopes off the right side of the interval, we get a little bit bigger change in y in the end. If we use midpoints, so use these midpoint values as my slopes, again, we get something slightly different for that change in y. But that's the idea. It's the same sum, just we're thinking about it in a little bit different way. Let's go ahead and do one. So this is going to be a snowfall accumulation, and I'll probably have to zoom this out a little bit here to get the whole thing on. But we're just going to take this snowfall rate and accumulate that over time. So this one, let's go ahead and track that down just a little bit more. There we go. So we're going to go ahead and take this time 0 and this rate of snowfall, so inches per day, so 4 inches per day, then 3, then 1, then 0, and just first off just sketch the rate function. So this is going to be my rate function. So I start off 4 inches on day 0. Then we're going to go to 3, looks like 1, 0, -1, -2, 0 again, 1, 2, and then -1. So this would kind of follow this path right here. So we're going to come down, something like that, maybe come up and then drops off again. So that would be my rate function that I'm looking at right there. The accumulation is going to start adding all of these up. So we're going to start at 0, and over the first day, we're going to accumulate 4 inches. So I'm going to start at 0. We could start actually anywhere. Maybe we already have 6 inches of snow on the ground, but I'm just going to assume we're going to start with nothing. And we'll go up 4, right there. The next day we're going to go up 3, so that takes us up to 7. The next day 1, so that takes us up to 8. The next day is 0, so we're going to just kind of flatten out right there, and I'll go ahead and connect a few of these here at the beginning. So that is going to be looking at this 4, accumulation of 4 inches, 3 inches, 1 inch, nothing over those first 4 days. Now we'll go down to 7 for that next -1, and then another 2, so that drops down to 5. So that covers -1, -2, 0, going from 6 to 7 right there. Go up another 1 right there, so that's 0 and 1 accumulation, and the last one we'll be able to fit on this graph is the 2, so 2 right there. So that's kind of the idea, is you're just adding up all these accumulation values over those delta x's. Our delta x in this case is just 1, so it makes it kind of easy to plot those just every unit as you go through. There's a few questions here at the end that we'll go and answer based on those graphs. So when did the amount of snow depth appear to be the greatest? So uh, taking in mind that this is just a rate, we're not really going to answer anything off this rate. What we're looking at is right here. So the amount of snow was the greatest right here around, if you want to say t equals 3 for that one, or t equals 4, kind of the same thing right there. We had no snow accumulation right there at the peak, so it kind of covers an interval. When did the amount of snow appear to be the least? That is actually just when we started, right? So just because you go up and you go down doesn't mean you're going to have, you're not going to get back to where you started necessarily. Maybe you will, maybe you won't, but for us it's going to be t equals 0. That's the least amount of snow. We accumulated some, but we never did lose enough to get back to where we were at the beginning. What is the total accumulation of snow from the first day through the end of the 7th day? So that's going to be, and actually, end of the 7th day. So we're going 1, 2, 3, 4, 5, 6, 7. Let's just say that's right there. This guy, actually, end of the 7th day will probably be right there at the beginning of the 8th, equals 8. So let's go ahead and say that's going to be right here from 0 up to a height of 6. That'll be 6 inches on that day. And normally I might want to make that a little more clear rather than 7th day, maybe t equals some value right there on that, but we'll just go ahead and say 6 inches. And then finally, how would I express this as a definite integral? So if we're going from 0 to end of the 7th day, I would say that 0 to 7, and then we want this f of x dx, or in our case, it might be rather than that f, I think we called it, let's see if we gave it a name real quick. So I'll come back up, and this is, didn't really give it a name, so we can just call that f of x, or you could say r of t if you want, and probably it should be for 7 right there. So I'm going to go ahead and change that value back to 5. Let's go and say this is going to be end of the 7th day. We'll call that 5. And then this is going to be either f of x dx, or you might even do something like this, r of t dt, where t goes 0 to 7. So counting 0 is kind of the beginning, but end of the first day would be 1, and then end of the 7th day would be 7. So that's what you should get on those guys. We'll go ahead and continue to look at some of the rest of this in another video that kind of gives you an idea of how accumulation works and what you're going to be doing with those. In the next video, we'll be looking at maybe doing that with some of these predefined functions with a certain number of subdivisions, calculating out some delta x's, things like that. So stay tuned for the next video, and that'll do it for now.